morning, everyone. Can you hear me properly? Yes? Great. So the talk now will be about CMAF. Maybe you have been hearing this acronym already. Just a quick word on myself. I'm Benoit Brieussel. I'm a product marketing manager at Viaccess Orca. In Viaccess Orca, we provide solutions for content protection and for content management systems. So if you look at the kind of products we provide some CAS, DRM, secure player solutions and security services. And we also provide TVAS, TV platform solutions. So we have like end-to-end solutions that we provide to TV operators in the market, just to give you a background of myself. So back to CMAF. What is CMAF? Have you heard about CMAF already in the past? Yes? So I will give you a bit more details about this, the benefits and so on. So first of all, what is CMAF? CMAF is a standard that is driven by the industry. So you have the big names like Microsoft or Apple that are following this and supporting this standard. The good news with this standard is that there's really good market adoption that is possible. One, because the technology that is used behind CMAF is existing technology. There's no disruptive technology as such. And two, because if a system or an appliance in the system is not CMAF compliant, still the system will work. The CMAF metadata or whatever will be ignored and still the system will work. So with these two advantages, this makes CMAF quite a good technology, a good standard, a good format to bear in mind to deploy in the market. Okay? On the right side, you see some acronyms, some names. Do we have techie guys here? Do we have some... Okay, maybe we'll not go through all this today. But just to let you know that there is a lot of standard and expertise behind this, relying on existing technology, right? So why CMAF? It's all about user experience. If you look at why people stay and watch movies on TV systems and video systems, it's because it's usable, it's easy to use, and it brings all the quality that you can expect from a TV system. Also, we see that if you have a good user experience on the OTT systems, we observe that some operators really consider moving from IPTV to OTT, because OTT is maybe a bit more simple to and cheaper to deploy in the market, but the user experience is so important that still it has to be resolved first. So CMAF contributes to a better user experience at the end for subscribers and people that watch TV. If you look at OTT, you may have seen some rebuffering, some scrubbing, so like latency. OTT is improving a lot on the rebuffering side or the scrubbing side, so the ability to show thumbnails on the progress bar. But how about live latency? That's one of the things we will see today. So let's go through directly now to the benefits of CMAF, of this standard. The main reason for creation of CMAF is first to address multiple devices with one single stream. Okay? So this allows to reduce the cost of deploying systems and then to use the saved money to improve the user experience, as an example. And this reduces the risk of problems as well, because with one same stream you can address multiple devices. And the second benefit that we can see in the market is the low live latency. So I will explain a bit this use case as well. But the use cases that are targeted is sports, interactivity, esports, everything that requires instant reaction and watching compared to what is happening in real life. So let's go first to the first benefit, the single stream. If you look at today in the systems that is deployed in the market, for the same content, you have one stream that goes to Android tablets, Chrome browser, and so on. You have another stream that goes to Apple and Mac OS and so on. And you may have another stream for some smart TVs, for Edge browser and so on. So this creates complexity, additional cost, and risk in the system itself. Okay? If you have a CMAF compliant system with one stream, you can deploy your content in all these different devices different DRM systems. So that's really the first benefit in the market that you can observe with this standard. The second one, you remember, is about this live latency. So let's assume you are watching a football game. Yesterday there was a basketball game I could see. I don't know if you have seen this final on the basket on the TV screens, local kid from university, I think. Maybe you have the US Open tennis, you have many different sports. I'm sure you have been already experiencing this. So let's take example of the World Cup, for instance, or a football match that happened in France, for instance, last year. Was quite a famous event, very important for many people. If you are, let's say, on a traditional TV, there's a goal. If you have low live latency benefit on your tablet or on your smartphone, slightly, few seconds after, you will also watch this event. Then you go to another scene, something happens during the football match. Again, with the traditional TV or with the low live latency system in place, you can watch what's happening in the real stadium. Now, if you're not with low live latency, like 30 seconds or 40 seconds later, you still watch the previous scene. So if you receive a tweet, or if you have a neighbors shouting here, and you watch this event 40 seconds afterwards, you're frustrated. It's really frustration. So this is one of the main reasons why also OTT is not completely deployed in all the cases, is because of this effect. And of course it goes the same with the scene afterwards. So this is really this delay between what you watch on traditional TV and what you watch on OTT over the internet. Okay? So let's go a bit in the technical details. Where does this come from? So if you look at the first line, this is a kind of traditional TV you may have, or an IPTV, you may have between 4 to 6 seconds delay. If you go to the OTT delivery, we observed with, let's say, basic components in the system, around 30 seconds, 40 seconds. It can be even more than that. The two main critical paths in the critical path are the packaging itself and the player itself. So the packager on the backend side that creates the video, and the player on the device that is getting the stream, decrypting, decoding, and putting on the screen, okay, for playback. So these are the two important pieces in the system to monitor and to optimize when you want to reduce this delay, when you watch on OTT live sports, for instance. One slide a bit deeper in the technical part. How does this work? Basically, if you look at on the player side, which is the most critical part of the system, if you are not low live latency, if you are not CMAF compliant, you need to wait for the entire fragment of the video to be downloaded to start the playback. So if this fragment is like 30 seconds, for instance, you have to wait for the 30 seconds to be downloaded to start the playback, okay? Now, if you have CMAF compliance or if you have low latency technology in place, you can split this fragment into chunks. In this example, 5 chunks. And the player will start decoding and decrypting and playing at the end of this chunk. So in this example, I have 5 chunks. This means that the delay can be reduced by 5 times compared to a non-low latency system compliant. Is this clear from you? It's a bit technical, and I think it's interesting to understand what's happening really inside the video player of the system solution. So now let's look at the workflow in general. How is it working? If you look at a simple system, very high level, for clear stream, not encrypted streams, you have the encoder and the packager on the back end that continuously create the stream on the fly, let's say. On the device side, the end user click on the play button, okay? So the player will make a request to CDN, and the CDN will relay this request to get indeed the stream that is needed to play on the device. So the origin server or whatever on the backend side will return the stream through HTTP chunk system instead of regular streaming as it is done without CMAF. And then the CDN will relay this, and on the device side you get the playback. Okay, so this is how this is working, high-level point of view. So this was with clear streams. Now we have to add the security part. We are talking about pay TV. Usually with sports, it's a lot of money that is used to acquire the rights to display and distribute sports content. So there are some security requirements and implications that are very important to implement to get the right to deploy this content, this type of content. So one aspect to bear in mind when you deploy a system for low latency with encrypted streams is the type of algorithms used to encrypt the stream, encrypt and decrypt. So there are many different algorithms. The two most common ones are CBC and CTR. So what you have to bear in mind to address as many devices as possible is to use the CBC algorithm. I will not go into the detail. It's maybe a bit too complex, but just bear in mind this acronym is important to configure in the system to ensure reaching as many devices as possible. Okay? The second thing which is important when you introduce security into the system is the license request. So what does that mean? When you go to the in-ucast world, the OTT world, the device tend to make a lot of more requests to the server to get the rights and the keys to play the content. And this can take a few seconds, okay? So this is a classical diagram where you get the content that is encrypted on one side and the player embedded into the device and the application, the TV application, will request for the keys and the rights associated to this content. The point here is that getting the keys each time you change the TV channel, each time there is an event that creates a request to the server to get the keys, add a delay on top, and then the start is impacted. So we want to avoid this. Adding security should not impact the performance of the fast startup and the delay of the low live latency. How does this work? So let's assume first you are in a reactive mode. This is where you get this delay. So in this case, on the device, the end user click on the play button again. The player will request the rights and the keys to the license. The security head-end will return these keys and rights in a secure way. And then you get the same as we have seen before, just like with the clear content. With this, you can have the playback with the secure content. Now let's go to the proactive mode. In the case of proactive mode, you could assume that the licenses are requested. The license acquisition is done before the end user click on the play button. In this case, the licenses are already on the device before the end user click on the play button, which means you are back to the clear content use case with no impact on the startup time and on the delay itself that is brought. Okay? Just to give you an overview of when you introduce secure content on the system, this is very important also to keep in mind to not impact and get all the performance of the CMAF protocol. And you get the playback in that case, of course. So here are the three key takeaways of this presentation. First, user experience drive a lot everything. To avoid people to quit the service, to have people watch the video content that have so expensive to be acquired, pay a lot of attention to have the best user experience possible that you can bring. And this live latency is absolutely key in use cases like live sports and gambling and interaction, phone calling and so on. Second thing is to simplify all the system. Have one stream to address many different devices, especially when the streams are encrypted. And the third point to bear in mind is that it can be complex. You need to combine multiple expertise, like how to address multiple types of operating system devices, how to have a good packager, and how to bring all the security constraints, all of this all together that works well in the market and being scalable. So be careful to rely on really good product for that, okay? Good solution. So as next steps, what is I think is important to bear in mind is first, CMAF is commercially deployable today. So you can get already some advantage of, as I presented, already by today with some already solutions here you can see. What are the next steps related to this? So the next step is, in our view, in my view, is really important to measure concretely in the market the promise. So we promise there is a much lower delay. We promise that indeed there's no regression on the performance and in general of the system. So the important thing will be to measure concretely this and maybe optimize the delay depending on different conditions, different contexts. Is it Wi-Fi in countries, in regions, at home, in mobility, everywhere? Maybe we can define automatic delay instead of putting a fixed value on the configuration of the system. We can also imagine to have an automatic algorithm that can adjust depending on what's happening in the context. So just to give you the next step we see is really to go to this pragmatic way where to measure concretely on the market with data in real time what's happening with all this user experience functionality. So if you want to see a few demos of this, please come by to Viaccess Orca booth. We have a great low live latency demo with from internet, really coming from France. You have a stream coming from France, played on here in Las Vegas. We have also other demos for general system. Please come by. I will be very happy to see you there and show you these demos. And I am here also for answering any of your questions after this session. Thank you for your attention.